Hello again, I'm Ben Canning, and we're going to conclude this collection of videos for this unit. There's still more collections for this unit, but we're going to end this idea of gravity's effect on velocity. As always, you need 3 or more bullet points worth of notes, so 1 to 2 sentence summary and your follow-up questions on Google Form. So we started with this big idea of how do we predict and describe the effects of pushes and pulls on motion. And we now know that gravity pulls on an object and it changes its velocity, and we know how it affects its velocity. Specifically, it causes some acceleration. The unit focus, so far we have analyzed the effect of gravity on velocity, but how do we predict how long it takes to fall? Meaning, we've got this kid right here who jumped off this lifeguard tower. It looks like he's having a blast, but how do we know how much hang time he's going to have? In other words, how much time before he hits the ground over here? And if he jumps even higher, can we predict how much longer it would take for him to hit the ground? And is it that much longer, or is it just a brief moment? So in order to do that, we're going to need to kind of look at gravity a little bit more, specifically at position. But this collection we focused on looking at how fast things were moving because of gravity. And so looking at how far they fall or how long it takes to fall is where we're going to go with next. And so we might be able to predict how long it takes this skydiver to fall to the ground if he goes instead from like a normal airplane to jumping from a hot air balloon that's way high up. Or what if he triples his heights? Does he get to fall for 3 times as long, or 4 times as long, or not as long? What's the relationship in this scenario? That's it for this outro. Please do 3 or more bullet points of notes, a 1 to 2 sentence summary, and your follow-up questions on Google Forms.